Hi everyone, today we'll be talking about how to solve quadratics by using the factoring method. So we're going to be utilizing the factoring skills that we've used in the last unit to help us solve these quadratic equations. Alright, so first we're going to talk about the zero product property. If the product of two expressions is zero, then one or both of the expressions will also be equal to zero. So if we had a and b are expressions and we multiplied them together, okay, and they equal 0, then we would say that a is equal to 0 or b is equal to 0. Right, so that would be like the math problem, 5 times 0, okay, or 0 times 5. One of them would have to be 0 in order for the answer to be 0. So we can think of the same thing here when we're multiplying binomials or polynomials. One of those expressions, so x plus 5 is an expression and x plus 2 is an expression. If the product of those two expressions is equal to 0, then that means at least one of these also has to be equal to 0. So this is where we come into turning those factors into solutions. So if x plus 5 equals 0 or x plus 2 equals 0, then we could say that that in this case, if I subtracted that 5 from both sides, I would get x is equal to negative 5. Or if I subtracted 2 from both sides, we could say that x is equal to negative 2. Right? So this is what we had talked about over the last couple of classes. Our factors are always the opposite of our solutions. All right, so these are just going to be a couple try on your own problems that we'll do in class. All right, so now here are the steps that we're going to use to find the solutions by factoring. So first thing you would do is take your quadratic equation and set it equal to 0, and then factor completely. So this piece here where it says set the quadratic equal to 0, that's a really important piece because they're not always going to automatically equal 0 or equal y. So we might have to move some terms around so that it does equal 0. And once you get it equal to 0, then you factor it out completely. Then we're going to take each factor and set those equal to 0. So it's kind of like what happened up here. Okay, we had that factor x plus 5, so they took that x plus 5 and set it equal to 0. They took this factor, x plus 2, and then they set that equal to 0. And then we'd solve for the variable. And you're often going to get more than one solution. Sometimes you get 1, sometimes you get 2. All right, so now let's come down here and take a look. So here we have a quadratic equation. I know it's quadratic because my biggest exponent is 2. But it does not equal 0. So right now I need to make it equal 0. In order to do that, I need to start moving some terms around. I've got to get all the terms to one side. Now, here's one of the things you want to kind of think about. It really doesn't matter if I move these terms here over to the right or if I move these terms here over to the left. But what you may want to consider is always trying to keep that quadratic term, the x squared term, positive. So if I were to move these two over here to the left, I'd end up with a negative x squared term, right? Because if I subtracted 2x squared from 1x squared, I'd end up with a negative 1. I honestly don't want that. I'd rather have a positive x squared. It makes a little less work for me. So what I'm going to do is I'm going to take these three terms and I'm going to move them over to this side. To do that, I use the opposite. And I'm gonna move them all over at one time. So to move this x squared, I have to subtract it. To move my 2x, I have to subtract it. To move my 5, I have to add it. So here I go. I'm going to subtract my x squared, I'm going to subtract my 2x, and I'm going to add my 5. And I'm going to do that over to this side here. So when I do that, these here all cancel out. They're gone. And now I can combine my like terms over here. So my 2x squared minus x squared is going to just give me x squared. I have nothing to combine this negative 2x with, so he's just going to come down. But that negative 4 plus 5 is going to give me 1. So 2x squared minus x squared gave me x squared. nothing to combine the negative 2x with, so he just came down as minus 2x. Negative 4 plus 5 is a plus 1. All right, and now I'm going to set that equal to 0. So this whole thing equals 0. There's nothing left on this side of the equal sign. We canceled it all out, so we put the 0 in its place. All right, now that I have my quadratic in standard form, now I can go ahead and factor. So if we remember from last unit, to factor, we'll start with first we start with, do I have a greatest common factor? And in this case, I don't. So now I'm going to come over here to my magic x. I'm going to do my a times c, so 1 times 1 gives me 1. And then my b, which is a negative 2. So I need to find two factors of 1 that also add up to negative 2. So this is where you can utilize that graphing calculator to help you out. So we end up finding that negative 1 times negative 1 multiplies to a positive 1, and negative 1 plus negative 1 gives me negative 2. All right, so now I've got those two factors. So now I'm going to utilize the box method. I'm going to put my first term and my last term into the box, and then my two terms here, where we split up that negative 2x, they're going to go here and here. And now I can factor, pulling out those greatest common factors. I know that I'm always going to have an x in those two spots, always. So my GCF of these two happen to just be x, so that's all I have to pull out. Now I can look here. All right, so my greatest common factor of negative 1 and 1, well, since this term here is negative, then it's a negative 1 that I'm going to pull out. And then same thing here. Since this guy here is negative, I'm going to pull out a negative 1. All right, so now my factors are going to look like this. So I get 0, and I just brought this 0 down. You can always put your equal 0 over on this side if you prefer. Doesn't really matter. All right, so now I can take my two factors and set them equal to 0. Now, since they're exactly the same, I'm only going to do it once. Why would I do the same math problem twice? That would be silly. All right, so now that I've set that factor equal to 0, I can, I would add that 1 over to the other side, so we get the solution of x equals 1. So when we are factoring, solving by factoring, because I got the two factors that were exactly the same, that tells me that my parabola is only going to have one solution. Right? It means that that parabola only touches the x-axis at the vertex. And this is exactly where it touches. All right, so these two problems here also try on your own. This one here, or both of them, are already set equal to 0. Be careful with A because it is missing one of the terms. So you're going to need to figure out which term it's missing. And this one here does have all three, so it should be ready to go. All right, and again, we will work on these in class together. I hope this video is helpful, and I will see you next time.